Hey everyone. Hey Yael, we took some spectra of the RL array. Aparajita, sorry we got cut off. And we got spectra last night. At the end of the night, we didn't get 2, we got 1. Beginning of the night, we got 2 last night. Tonight, we got both at the beginning of the night. Hopefully, we'll get 2 at the end of the night. So that's where things stand. I'm in the middle of taking some data, so I'll continue to do that for a few minutes, and then I'll be able to explain what I'm doing. And Aparajita, you and I can continue our chat on Pipit in just a few minutes. Welcome, Future Hope. Welcome, Rob. So I'm going to, this is session's being recorded, and I'm going to share my screen. But
Hi, Sid. I'll do a little bit. I'm not feeling too great today, and I have a math test tomorrow, so.
What was that? Sorry. Say that again. Yeah.
I'll head out in a little bit.
No problem. Of course.
Yeah.
Of course. No problem at all. You all should be able to see my screen now, and you're going to spend another 5 minutes on this mask before moving to the next one. The atmospheric conditions are very good so far today, touch wood. The images are very sharp. And after we finish this mask, we'll go to the one that's highlighted here, index 11. Rina, we are about, I don't know, 2 minutes away from being able to move to the highlighted target. And again, this one hasn't been observed before. I meant to say 4 minutes away. Okay. So Aparajita, the other thing about Pipit is, instead of running it on our laptops, there's the option of running it in the cloud. And X brought that up as a possibility. That, getting an account, using my UCSC.edu account to get an account in the cloud, and getting some data storage, and then running things there. That would be a more uniform way to do it than on our individual. It'd be faster and more uniform. If we have a single repository where we save all this, that would be better. I did check with,
especially on my computer, because it will take longer on my computer.
Yeah, so let's just run it there. There's also my server at Santa Cruz if you wanted to run it on that, but let's try the cloud option. X suggested it. I'll run it by Deborah to get details of how we set up that account. Couple more things. One is Marla clarified which mask she's running Pipit on, and that it doesn't overlap with the ones we are looking to run Pipit on. So she's running it on all the dwarf satellites of Andromeda. And I don't think, I know that doesn't include M32. It may include some of the other dwarfs that are closer to it, that are around M31's disk, but for the most part, she's targeting dwarf galaxies, satellites of Andromeda, satellites of the Milky Way, and globular star clusters in the Milky Way. Those are the 3 things. So the masks we are reducing, like M33 disk, M33 halo, M31 disk, M31 halo, those are things she's not touching, so it's complementary. A third person who'll be running Pipette is Elisa Toloba, a former postdoc. She'll be running it on the Virgo cluster, DEIMOS mass, where we targeted globular clusters. So it's 3 disjoint data sets of masks that will be responsible for. Our group will be responsible for M31 and 33, but not dwarf satellites. Marla will be doing only dwarf satellites and star clusters, and Elisa will do Virgo cluster, globular clusters. So there was one other thing. What was that? Let me just remember. There's one other thing that I'm blanking on. Running it in the cloud. Division of labor, who's going to do what? One other thing. It'll come back to me. I'm forgetting now what the. Rena, in 15 seconds, 10 seconds, we'll be ready to go to the highlighted target, M31 SR5.
All
right. Ready to go. So Rena's going to move the target. Change the telescope pointing. I'm choosing a mask name. So I keep thinking, Prajita, there was one more thing.
Okay. By the way, could you please share the recording of our meeting with Deborah the other day?
From our meeting?
With Deborah.
With Deborah, okay. I'll do that. I have that somewhere. Oh yeah, the last thing. Okay. 2 more things actually. So one of the advantages of running things in the cloud are things are scripted at an even higher level than we are running right now, right? Right now we bring in data from one night, we run the 2 setup commands. The second setup command creates the separate setups, one for each mask observed on that night. Then we run Pipette. So X was explaining that all that is scripted. It can be done automatically. We don't have to go in and type those 3 commands. So that's a slight convenience, especially when we're. All right, thank you, Rena. All right, I'm just going to go off and do course alignment. One moment. You guys, I'm aligning the first M33 mask, M32 mask. Wow. I've never seen something land so close, even on at the course line. I'm still going to move the telescope, I guess. I've started a fine alignment. So it's taking 20-second exposures just to get the landing boxes. You know, the course alignment was dead on. I didn't have to do anything with the course alignment. It was right on. So I'm now doing a final alignment.
CCD readout complete.
Ooh. Wow, how can the course alignment be right on and then the final alignment be so bad? What's going on? Do I need to redo the course alignment? Look how bad it is. Redo the course. That's so bizarre. Look. Okay. I grab guider image again.
Just won't move. It didn't adjust anything.
Okay. Yeah, it's very close. Let's see what's going on. I hope there's nothing wrong with the alignment boxes. If there is, we'll skip to another mask. But the boxes were okay, right? For all the masks.
Well, this is number 5. We haven't observed it yet.
But when you did the imaging of,
At the ID box. Yeah.
yeah, they look fine, right?
It's identifying them.
Yeah. I want to do another fine alignment in the hope that something, I mean, it's in 0th order. Everything looks fine on the, we'll do another one, okay? Jim?
Only picking up 2 stars.
Yeah, I mean, this image looks fine, right? This image right here looks fine to me.
Yeah.
I'm not seeing the alignment. Oh, there's one box. Okay. Let's see what's in here. Oh, look at that. It's right off the edge. And here, I don't even see it.
CCD readout complete.
Sorry.
Right.
Something is wrong. Two of the, oh, look, two of the,
What was this exposure? No, that's D2.
are these the original images that were?
This is the mask image I took. this
Looks fine.
afternoon.
Yeah, looks
Yeah, it
fine.
looks fine. It was picking up the boxes.
This one looks like a slit is the only thing.
You're right. The other ones look fine now.
Yeah. So we're looking at the, let's look at, sorry. Jim, please tell me again what to do. Okay. Okay. Okay.
So the problem is, what's the log?
Okay. That's right.
It doesn't have any recommendation.
Yeah, so it's trying to fit. Can we turn it on again? So I think if we would do X, Y.
Should I just do that on the command line? So it's GXY?
I don't know, it would just be
MXY space -20. And that just moves the telescope by 2 arc seconds in X. Should I now take start final alignment?
Yeah.
Why did it not find the boxes at all? That's what intrigues me. Yeah,
It's weird because it knows where the boxes are.
and yeah, it's imaging them fine. So what's going on?
well, the imaging is due to overlap.
Hmm.
CCD readout complete.
Same problem. And now one is gone.
The other one was gone before too.
Should we try to align P2?
It's
Since
not the right
it's-
time of the night for parallactic. So we could try to align 6 and try to do 5 later, but
This is the current image.
I believe so. Why is it not?
There's one box and there's a star in it.
Yeah, why is it not finding these? I mean, that must be 6. Oh, that must be 6, yeah. Shall I change the display range so you can see the boxes better? Yeah, so just so I'm going to change the display range a little bit. Yeah. Yeah, there's 3. Yeah. And this, yeah, and this slit is being treated as a box. I don't know if that's throwing things off.
Can you go into the ID boxes thing and like delete that one?
Everything's got a star in it. So this one's got a star in it. Look at that.
Why that would throw everything off.
Yeah. This has got a star in it.
Yeah, the only thing. the only-
Yeah. I don't know if that's somehow throwing things off because it's got a star here. How do we do that?
This is, can we like delete this? If we like, click on,
Yeah, I
can
think
we,
it is.
or there has to be a file where it saves the location, the box positions, right? Can we like delete it from there?
It's not allowing. Jim, how do we delete that box?
Did I just accidentally delete one of the other boxes?
Don't know. I think one of the boxes is gone. This is one of the alignment boxes. Yep.
It's number,
Number.
it's 11. I
Let-
did delete one of them somehow.
So let's, yeah.
So we're gonna this one.
Okay.
Good.
Yeah, so to the folks on Zoom, we're having some instrument issues, so please bear with us.
Hi, Roger.
Hello.
Software issues.
Yeah.
I see that you're wearing a Akula hoodie.
What was that? Sorry. Yeah, yeah.
I see that you're wearing a Akula what's your hoodie.
Yes, I am. I'm wearing your school hoodie. Yeah, absolutely. Thank you for giving it to me.
You're
Yeah.
There we go.
Wow.
That was throwing it off.
How did you do it? Wow.
Sorry, my bad for not noticing that one was a
Slit, but you know, I don't,
guess I
don't know how that got in there.
didn't think that throw everything off of my poor angular resolution.
I think, I wonder how that slit got in there. Shift of what in index?
Yeah, I'm wondering if it, because it was just one of the boxes was odd or something.
Yeah, something like that. It must be at a design stage, must have been a glitch in the mass design file. I hope 6 is okay. 5 and 6 were designed at the same time.
Well, now we know more quickly though how to
How to
solve it.
solve it. Yeah. And besides, 5 should be exactly the same. 6 should be exactly the same location. So let's see.
CCD readout complete.
Beautiful. No moves to send, right? The seeing doesn't look terrific, but that's because we're at high MS.
Getting decent thing on the guider is some surprise.
1.5, it says. Should we do, I wonder if we should do a Myra?
But you'd probably be doing it right around the same location,
Yeah, as before.
couple hours, but
I'm worried about the image quality. We won't get very good spectra if the image quality is 1.5, which is what we're getting on this guide frame.
Yeah, and it looks like. It seems like it's starting to.
Yeah.
you both the information.
Okay. The seeing's good. Let's do a Myra. Couple of hours west. Okay, thank you. And the change we've made to the alignment boxes, can we propagate that to mask M31 SR6? I think we should do that.
They hitting a booster elevation
I would do,
here.
I'm tempted to say a couple of hours west because we'll sit on this field for 8 hours. Maybe at least an hour west. Yes, please. Not sure what happened, why the image quality is so bad. It's a separate problem from the not being able to align. Let's see what happens. 1.5 arc seconds is what I've calculated for the seeing from this. Yeah, even though, no, in fact, some of the stars are really sharp in one of the axes, so something's going on. Okay, no, so, yeah.
Yeah, is it? Can you do so make sure it's not just an issue, you know, with like a galaxy or something?
No, so what I'm seeing, very clear pattern, is the stars are very sharp in Y, but they are broad in X. All the stars, all 5 stars. I'll pull it up on the image so you can see, but that's basically what's going on. Stars are really broad in X.
Should be getting. Could it just be chromatic aberration?
You know, the filter is not wide enough for. You see what I mean? Do you see this? Okay, I don't know if you can see this. Yeah.
It's super elongated.
Super elongated, right? And that's happening everywhere. Yeah, it's not. Yeah, it's not doing this everywhere, but it's doing this in a lot of places. Very elongated. Very elongated on the left side of the mask, at least. On the right side, it's not so elongated. So Rena's running a Myra. Prajita, let's remember to talk about KOA, K-O-A, which is Keck Observatory Archive. That's the one thing that we haven't discussed yet.
Okay.
We should be getting data, our raw data straight from the archive to do this production pipette run. So to the folks on Zoom, what we're doing is we're realigning the telescope to make sure you understand what's going on.
DCD readout complete.
Wow. 0.57. Okay.
Yeah.
It's very good. Yeah.
The seeing is 0.57. That's crazy.
From the Myra, Arena's estimating a seeing of 0.57.
Wow, that hurts.
Yeah. Well, it's at very high MS right now, M32 for what it's worth. So not losing quality time, but we should have, yeah, we should hopefully get back on track soon. But the image quality, the way it was, taking spectra of such faint stars wouldn't have given us very much. So makes sense too. Sorry, what was that, Arena? Mira's done. Oh, thank you. Okay. Okay. Yeah, I'm going to do another fine alignment, and the box file has been changed permanently for this mask, right? Evan and sorry, not Ivana. Think of you as your advisor. Has the box file been changed? Okay. Okay, and then. Okay, so I'm just going to do a start final line then. Started. Jim, is there a way to copy this box file over for 6, for mask 6? Same alignment, but I wonder if we should look at the image of that mask to make sure that that is the same problem.
Yeah, we can.
Yeah,
Okay, let's finish this one. Hopefully this goes well, and then we can look into that. I'm not seeing, oh, I see. Wow. I thought the grating was already at 0. Maybe it wasn't. I'm surprised it did a grating move, Jim. I thought it was at 0. 0th order. Is it? Oh, but it should. When we went to mirror? I guess so. I guess so. Yeah, okay. Got it. Sorry, folks,
Okay,
we're
see.
some technical problems on tonight on trying to align a mask. So that's why we see these worried faces here.
Is this one of the alignment steps?
What you're seeing on the screen is not. No, this was just used for a Myra.
DCD readout.
What's mine?
Myra is the mirror alignment. So
Oh.
this window, yeah. There we go. Oh, much better. The image quality is much better. So let's do send moves retake. Before the x-axis graphs were much broader. So it was worthwhile doing a mirror alignment. So worthwhile doing a focus. So if the image quality is better than last night, we'll be able to get away with shorter exposures than we spent 89 minutes on C1 last
18.
night. All right. let's see.
18 minutes is what you're thinking, Roger?
If for
it's
these
better.
masks at the very beginning and end of the night, we'd probably do an hour. But for the ones, if the image quality continues to improve, then we should be able to get by with shorter. And if we don't do 7 masks tonight and we do 5 or 6, it won't be the end of the world. We better get good data. So the answer to how many seconds we spend on this first mask will depend entirely on how good the image quality is. Send moves only. This is great.
How much is it
Right.
now? It was 1.5 before.
Yeah, what is it now?
What do you mean? What is it?
Calc. Sorry, calc. See?
You want to start the exposure?
Yeah, let's go over here and do let's go to
Yeah, 0.7. That's good.
You may need to just type in that wavelength.
yeah, don't do exactly. It's got confused. That's good. And I can pull it from here.
Yeah.
Oh, sorry, from there. Good. Otherwise, it's ready to go, and you can do a WFFCS GuhaThakurta, please, for that one. Oh, a 3.
Oh,
You can control C that and just do a 3. It'll either be a 3 or a 4, but we can do a 4th one later. Oh, sorry.
oh, it's okay. Says median 0.75.
That's much better than 1.5, so it's factor 2 better. So the seeing is saying 1.75 now. So for the folks on Zoom, seeing is a measure of how blurry or sharp the star is. The bigger the number, the worse
Okay, so
sharpness.
we wanted to start by,
I know, we've lost half an hour.
yeah.
But yesterday we wanted to start aligning at 8:30, and so we're closer to yesterday's place in terms of where we were. Okay, let me go in here and make a few changes. I can do this from here. Let's see where this is. It's pretty far out. We now just have to be an FCS whisperer and try to bring that into to the box. Well, the image quality is, yeah, good now. Much better than we had at this time of the night last night. So last night we started the alignment stuff at 20:30. We ran into problems after 29 minutes, redid the Myra, and ended up with 3 more 20 after that. So we can, I think we'll beat that tonight. So, because we've already done the Myra, even though we didn't get any data yet. I think those first 29 minutes were not very useful. So what we get now will be good. So 0.7 is yeah, good seeing. All right, let's see. My FCS whisperers.
What do you want to do?
What do we want to do next?
No, yeah, what are you doing?
I'm just trying to I'm trying to will FCS to start.
Don't mind if I look at the
Not at all.
empty boxes.
Yeah,
on
let me give
the-
this over to you. Okay, go for it. It's almost there. I'm just watching FCS come back in. It better not shoot across the box. That's the main thing we want to prevent. So I see there are very few students at Future Hope today in the classroom. How many people are there today? 10?
Sir, 2 absent. कितना है? 22. So, sir, it's 22.
22. Wow, that's a lot. That's a lot. Are you all in your school uniform today? I see. I didn't notice yellow yesterday. You're wearing a special uniform today?
No, sir, it's our PT dress.
Oh, I
House.
see. Okay. Okay. It's missing that box for some reason.
So I
Now.
have a question.
Yeah.
I have a question.
Yeah.
This is not, this is a split.
I have a question.
That's a sec. Go ahead. Go
I
ahead.
have a question.
Please ask.
Okay, does it? split?
So why surface temperature of sun is less than corona?
Is that under the options,
Why surface temperature of sun is less than corona?
I will answer in a moment.
Okay, so for the other masks, should I just go through now and manually mark them?
no,
No, I'll just change the extension back for different masks.
yeah,
Go to options.
Yeah.
Okay, I got it. Yeah. Okay,
So for now, we should set fifth extension because we don't get to 6 until the end.
all good. Now we have the boxes for, I could have literally just copied and renamed that file probably, but
Yeah.
whatever.
So what happened, I think, is Lara designed A1, A2, B1, B2, all of them in one batch. And then she did 5 and 6 separately. I think something went wrong with 5 and 6.
Maybe.
And it's the same alignment box that she used for all. So if she got it messed up for one, it got messed up for the other also.
Issue with the simulator.
I think it's a desimulator issue. I think so. I think,
Because it would have mark.
would have just given it a wrong priority and list accidentally for a slit instead of a.
But you have to specifically, it's pre-select the alignment.
Yeah,
starters, so
yeah.
it's
I'm,
The recommended.
yeah, I'm confused because if it got if desimulator thought it was an alignment box, it should have cut a square. And the fact that it cut a slit, and yet, so there's some mismatch between what's in the header of the file and the CAD file that went to the milling machine. Some mismatch, because the header thinks that's a alignment box, but clearly the milling machine, the CAD file commands thought it was a slit.
Yeah.
I think there's some kind of mismatch between
There-
those two.
Good look at the dot out file.
Yeah, the dot out file may look normal. It's in the FITS file that gets sent for milling. So something in between the header and body of the FITS file. I don't know how that got messed up, but something.
Yeah. I mean, it could maybe just be an issue with the slit map. Just the ID box software, however it automatically
Yeah.
does that.
Yeah.
Rather than.
I think you fixed it. I think you fixed.
Slit's very short and kind of chunky.
Can we zoom in on that? Because it could also be that it's truncated by the edge of the field of view. It could be a slit, it could be a box. Yeah,
There.
yeah, let's do that.
17.
But it's actually on this frame also. It's on
Yeah.
this frame, yeah. So why don't we do that? Do you want to change the,
You can do it if you want.
no problem.
Or-
I can do that. I can do that here. So what,
Could it be in a chips?
that's what I'm wondering. Something boundary between the chips or some kind of edge is what I think is going on here. Okay, that's too tight. Okay, so it's this box right here. Isn't it this one?
Yeah, it's all the way at the.
Or
It
is
looks
it,
right.
that looks right?
I think so.
There should be another slit right below it, right? Let me zoom out. I bet it's this thing at the top.
Maybe it is. Maybe that is an alignment box that fell on the edge.
Yeah,
Oh.
I'm not seeing the same pattern here. Do you see this one too like that? Oh, it's flipped, isn't it? No, it's not flipped. Let's make sure. Let's make sure. Let's go over here. That's one alignment box. There should be another. There's another. There should be a third alignment box here, there. So I don't think it's flipped. So let's see. Then we go to this alignment box over here, this one here. And it's really, you see how the slit is truncated? There's some vignetting going on. So where is it relative to these? Let me zoom out. Let me zoom out. That's what I need to do really. So it's this.
It's on the other side of that white line.
It's this guy here.
I think it's that one. Maybe.
I'm not seeing the pattern. I think it's here. You see what I mean? I'm not, the pattern that I'm seeing here, is there a way to zoom in on this pattern or something? Or was it this thing that the slit was on? So you see, I'm not,
It was finding this.
so you see, I'm not seeing a row. You see, there's a row of more or less vertical row of three. I'm not seeing that.
I don't know.
I,
Is it one?
I don't think it is,
No.
because I think there's some kind of aliasing going on here. It's zoomed out so much that you're not seeing all the slits here.
Yeah, that's pretty.
But I'm not seeing two slits to the left of this box at all. You see that, this slit? There's something bizarre about this. I don't think this is the, this is SR5 align.
You're looking at SR6.
But they are the same.
Oh no, the slits are different.
The slits are different.
Oh yeah, the alignment
Oh,
boxes are the
okay,
same.
boxes are-
That's why. That's why. Okay, that would explain why we're not seeing the. So in SR6, since the slits are different, I wonder, had it also picked a slit as an alignment box in SR6?
Well, I don't know, because the box file, when we clicked on ID boxes,
Uh-huh.
it was empty just now, and I don't remember.
Ah, gotcha. No
if
problem.
It also selected this one.
I see.
Um,
We should be good now, though.
something.
We should be good.
Yeah.
I think these 5 boxes should be fine. That's why the slits are different. That makes sense. That's why we're not seeing the same pattern of slits. Okay. Why is the surface temperature of the sun cooler than its corona? Do you know why? This is a question from one of the Future Hope students. Doug, Aparajita, help me here. I don't remember
I
either.
don't think I know.
It is low density in the corona, indeed.
So then
Does it just have to do with heat propagation?
I think you. Doug is saying heat propagation, but I think you guys are. The density is very different indeed, where the surface of the star is much denser. It's almost as dense as rock. The average temperature of the sun is not too different from the average, sorry, not temperature, average density of the sun is not too different from the average density of the moon, as it turns out. But the corona is very low density plasma. So it might be a pressure argument, NKT, where the the N is much lower for the corona. T is much high, it has to be higher in order to sit in this. Yeah, and it's sitting in the same gravitational field, essentially, the same pressure. So to answer your question, we're not sure, but we think that it has to do with the way gas laws work, which is the pressure of a gas is equal to NKT, which is N is the density, K is Boltzmann's constant, and T is the temperature in Kelvin. And we know the corona is a much lower density gas than the photosphere of the star, the surface of the star. And if they have to have the same pressure, the corona would have to have a much higher temperature. Corona is millions of Kelvin, right? If I remember correctly. It emits X-rays. The surface temperature of the sun is only 5,800 Kelvin, 5,800. Fingers crossed that this spectrum comes out good. I'm going to make some notes in the observing log about all of this. All right, what are we seeing here? So this document you're looking at is the thing that keeps track of what exposures we've taken tonight and what we're, so you see that we took several images to align this mask. And on what I'm going to say over here is, let me see, after the first couple, we had a problem with alignment box IDs. They're called ID boxes. So the right name for the file, Jim and Ivana? Those are called ID boxes, the file you fixed. I'm just making a note in the log. Box. Box dot mask. I'm just putting mask name. Okay. Fix. So we fixed that. We fixed the box dot mask name file for 31 SR file. Right. Oh, and the image quality was a second problem. I think those were two independent problems. I'm writing some cryptic notes here, but Rina, what was the seeing from Myra? Okay, that's from the most recent Myra, and the final line that followed it had 0.7. Yeah, I guess so. So those are consistent, I feel. A lot of gibberish written here, but hopefully now we get some good spectra. Yeah, I see two independent issues, one with the boxes and the other with the image quality. They happen to hit at the same time, better than hitting at different times, because we were going to lose time anyway. So we're doing a series of 3 20-minute exposures on this mask. And what is the difference between blue and yellow jerseys? Different houses? Oh, I see red now also. Red, blue, yellow. All right, while this is running, Aparajita, one more thing. So the thing that I think we need to do in terms of a production run of pipette, when we do a production run of pipette, is instead of relying on my server and directories in which I've saved raw data from years past, we need to work directly off the Keck archive. And that would be a more efficient way. We specify certain parameters to identify masks. The archive works in a whole different way. You give it the name of the observer, the name of the PI, and the mask name, and it should be able to download all the data associated with that. And that would make more sense. And Carrie and Lara also felt that the most important masks to reduce are not the old M31 halo masks, because those papers have been written a long time ago. We're probably not going to revisit those papers. We'll ultimately want to reduce those, but they shouldn't be high in the queue. The highest in the queue should be the M31 masks, which is where we started, and the M33 masks and the M31 masks in the fat region and fast region. So anything in the disk of M31, and in M33, everything in M33, because M33 is pretty much all disk. So that's the newest science. What Ivana is doing, what Amanda, Doug, so the newest science, or the most compelling science for now, is M31 disk, and including M32, but that plus M31 plus M33. So we should focus on those for starters. Then work our way back to the older things. But give me, if I can't do this, I probably won't be able to do this tonight, but I want to respond to Deborah and lay out a plan that's a little different from marching ahead right now. I'm going to set up the cloud and all that, a cloud account. Let's get there okay about turning off Flexure and Flexure correction and correction to heliocentric.
Yeah, and the other thing, yeah, the stuff that we could figure out.
Yeah, let's ask about that.
Yeah.
The other thing that's happening, sorry. You remember the broad emission line sources that I was talking to Liv about?
Yes.
they are planned for observations in. When are they planned for observations? In November now. Margaret has put them on the M33 masks. They're going to be observed in November. Because they're so unusual, we want to get second spectrum of those sources to make sure they haven't changed.
And remind me, are the targets in M31 or M33?
Say that again, sorry.
Are the Bell's targets in M31 or M33?
There's 6 of them, all in M33.
Right.
So Margaret, one of our collaborators, is going to observe over 4 half nights, 1 in October, 3 in November. In her October half night, she plans to observe 4 masks in the M31 fat region, not the fast region that we're observing now, but the fat region, the northern part of M31's disk. She will target some of the stars that Doug has identified as ones we've previously gotten spectra, but so they'll get a mix of new spectra and spectra of new things. Sorry, spectra of new things and spectra of things we've gotten spectra in the past. So from Claire Dorman's list, we'll repeat a few things, and then we'll get spectra of objects we haven't taken spectra of before. Plus, Margaret's primary targets are these, something like a dozen per mask. She has these high mass X-ray binary candidates. So these are X-ray sources for which she's trying to get optical spectra. So she'll do 4 masks in M31 in the fat region in mid-October. And then in mid-November, she has 3 more half nights, during which she plans to do 12 masks, 8 in that same M31 region, 4 in M33. And in those 4 in M33, she'll include the bells, the 6 bells. I had thought there was 1 broad emission line source in M31, but that was just my misreading of my notes. It had broad absorption lines. It's probably a foreground white dwarf, but it's not a bell source. It's not. Okay, we're about to read out. So let me switch us to a different screen. Fingers crossed that this looks good. About to read out.
DCD readout complete.
Oh, wow. Oh, wow. This is good. All right, let's do this. I like this. I like what I'm saying here. These things are faint, but I think we've got a trace in every. Zoom in a little.
Yeah, I see the continuum.
These 2 are faint, but then this one is back. This is looking reasonable. This is this 5 is the equivalent of a number 1 mask where the targets are faint. 6 has got brighter targets. So given that,
So this is the spectrums.
these are the red giants. 5 has the AGB in the red helium burning. It's not bad. I mean, I think what we'll see is hopefully some sharpening of the stellar continuum when the next one reads out. But this is not bad. This is better than we saw for C1 at the, even after the Myra and all that. We just didn't see this much continuum through. I don't know, wonder, this is an alignment star, I guess. I didn't expect an alignment star in the middle of the CCD array, right? So I wonder if it's just a bright star that happened to land on the slit. This doesn't look like an alignment box, right? I don't see this box edge. So I think
Yeah, I see what you're saying.
Yeah.
It'd have to be a very bright foreground star.
And do you see the red zoom in? It's here, right? These are our 3 alignment boxes on this side. These are the 2 on this side. So, and interestingly, it thinks this is an alignment box. It did get 3 on this side. You know how we,
Maybe it actually was there.
I don't know what's going on. I think
Well-
it's there. I'm seeing 6. Do you see 6 of these streaks here? So you see there's 1 streak here where the red box is. Second one here, third one here.
Yeah, perhaps the software just could not find it.
That's not an alignment box, I'm convinced.
Mhm.
This is again a bright star that landed on the slit. This one is not an alignment star either. It's a bright star on the slit. These 3 are alignment boxes. This, and just actually let's zoom out a little.
Mm.
Those 3 are clearly alignment.
Reading out the mask area.
That could be. How would it decides on its own based on the header, right? If it got the mask position wrong, that could absolutely have happened. If it got the mask position wrong, it read out the window according to a state. The mask is there. We can see 6 clear alignment boxes here. There's no question. If I go here, yeah. So that's the edge of the thing. So if I move a little bit this way, those are 3. If I keep marching across,
Mhm.
1 more, 2, 3. So we've got a total of 6 boxes. Something went wrong with the way the final line image read out. I think that's exactly, and it's related to, it tries to choose a readout size that includes just big enough to include the boxes. So if it mistook the position of a box, it just read out that part, couldn't find it. Final line got confused, but the box is really there.
Oh yeah, fine alignment. To make it more rapid, it only reads out there.
Yeah. And if it got the box position wrong, it affects the readout. So I think that's exactly what is going on. The box was cut fine, but there's something in the header that gave it incorrect information about where the box would be. And that affected what part it read out. That's good detective work, Jim. I think that's what's going on because we can clearly see the boxes here. In fact, if I zoom in, you can even see the, what you may call it. You can see the broad night sky lines that are, that's the only way you get that is if it's a, so you keep marching across, you get the broad lines here again. It's 2, 3, so you can sort of see the broad lines here. 3. This is good data quality, honestly. I just saw calcium triplet and stuff. So 3. That's not it. That's not it. These are bright stars. Until we get to this one. Again, broad emission lines. These are 4 and 5. And then 6 is off to the edge here. 6. And nothing more after that. Yeah, nothing more. So yes, mystery solved in the sense of the boxes are there. But look, you can see calcium triplet right there for this object. I'm happy with the data quality. All right, now I'm going to zoom in a little bit and so that we can, when the next one reads out, oh, it's far away. It's quite a, I want to see the improvement in quality. All right, Doug is going to talk about his background zoom image of Migu, right? That's Doug's dog, who is a beagle. That's Doug. Doug is left. Okay. All right, Future Hope and Aparajita and Rob, I have a little bit of time to chat now while we're waiting for about 11 minutes before the next exposure reads out. So Aparajita, I still owe an email to Liv to get things started on bells. We've made a lot of progress in understanding pipette and where we go forward. Evan came to the same conclusion you saw, or did you? He emailed me,
Yeah.
came to the same conclusion. So that's good. Two people completely independently have verified what was going on there. I think that only affects one slit, doesn't affect remaining 130. So you made a lot of progress in pipette, thinking of that. And a lot of progress both in being able to run it, but also in terms of optimal strategy. I think the person whose work is least affected by this so far at this point is Kang. But I would say if you're able to run pipette fine on your machine, I know it's going to be slow, but at least it gives you have a good understanding of how it works. That's the important thing about running.
That's exactly why I was going to run it. I mean, I was going to run it on A1 M33B. So, it's already done. I was just going to do it and compare the outputs. I mean, yeah.
So you sent things in the chat, those lines in the chat. Can you put that in an email also? Because I'll include that in my questions to Deborah email.
Just, yeah, sure.
And Aparajita, in her name, the O is essentially silent.
Oh, okay.
It's essentially, I mean, this is true whether it's, some people write it without the O, some people write it with an H at the end. But as far as I know, the pronunciation is the same either way.
Yeah, I know some people write it without. I always kind of assume that when the O is there, it's pronounced.
Yeah, it's very short, Deborah.
Right. Yeah.
It's very much like, I guess, there are, it's more common to spell it with an O, but there are, I think without the O spelling of Deborah seems to be more recent. Doug, we were looking at your pictures of Migu, and tell us about him.
Of my dog?
Yes.
Yeah, he's the best. He's a beagle. Best dog ever.
You have to tell people why he got that name.
Oh yeah, it's because I couldn't pronounce the word beagle. So I pronounced it Migu instead. And then that caught on.
Can we see a picture? If you turn off your video, I think we'll see a picture.
Oh no, that's monkey, right?
Oh, that's what it is. I couldn't tell. Oh yeah, you're right.
Yeah, that's monkey. That's my cat.
Very confused. This cat is very confused because it has a name of monkey. Oh, do you have a picture of Migu?
Yeah. Let me see if I can find it.
Okay.
Give me one moment.
Yeah, I can stop sharing if you want to share that. It's very important. All right, so let's see. We in 500 seconds. So if you look at this screen over here, in 500 seconds, it will read out the next exposure, right? And what we want to see is what changes between the new spectrum and this detailed section of the old spectrum. And what we are hoping is that these light vertical streaks that are stars will become slightly better defined, slightly sharper, slightly brighter. And let's see if that happens. Because what's happened right now is the thing we're looking at in the sky is relatively low in the sky. So the telescope is looking through a lot more of the Earth's atmosphere. But as the Earth rotates, this this galaxy or set of stars we're looking at is, because of the Earth's rotation, this thing is appearing to move closer to a vertical. So because of that, the telescope is now looking through less air than before. And the more air we look through generally, the more blurry the star gets. So we should see a less blurry set of spectra when this reads out in, when will it read out? In another 400 and some seconds, and another 7 minutes. All right, let's see something in the chat. All right, we're up to 825, so 360, that means 6 minutes to go.
I just forwarded you a picture of him, Raja.
Is it in my email?
Yeah.
All right. Hasn't shown up yet. There it is. Oh, that's so cute.
He was the best.
How old is he?
He died a while ago, but he was, damn, he must have been 14 when he died.
Wow. Looks like
He's pretty old.
Yeah, he looks like he's on a tile floor.
Yeah, that's the kitchen of my house back home in Brazil.
He must have been a little slippery for him.
He wasn't an inside dog. We sometimes let him in the kitchen, but
he was
we
mostly
had a
outdoors.
small yard that he would stay out there.
Okay, he had a kennel there.
Mm-hmm. Yeah.
Oh.
We actually got him because my dad's a cardiologist. And so one day when I was very young, he saved this person's life. And this person had a beagle who had had many kids. And then he just gave us he asked first, but we said yes. And then he gave us one of the puppies for free.
Oh, that's lovely. That's a great story. Oh, how cute. That's wonderful. I can show you something here, which is
nice. What's their name?
Corky, his name, yeah.
I love those kinds of dogs.
Shih Tzu.
They're all floof.
Yeah. He looked like a rat when we bathed him because all his fur was wet.
Yeah. Pets are the best.
They are indeed. All right, so in 200 seconds, so a little over 3 minutes, it's going to read this out. I'm really hoping that these will get sharper, but I want all of you to keep a close eye on this. When it says readout complete, one thing that will happen is you see all these hot spots here. These are cosmic ray hits. These are energetic particles that hit the silicon device and release electrons. And the silicon device, of course, just reports where electrons were released. It doesn't know whether light released them or cosmic rays. Cosmic rays are high energy particles. You can see this one came in at an angle and created released electrons along a line of pixels. Many of them do that. You can see this one, a line. So these will change because these cosmic ray hits are random hits that happen during the last 20-minute exposure. And this 20-minute exposure will have cosmic rays at different locations. So look for those to change when the readout happens. When the readout finishes, those cosmic rays, like this cosmic ray right between these two slits, will go away, almost certainly. They'll be hit somewhere else. Chances are this won't be repeated. But look for whether these streaks get more or less prominent. And I'll ask you afterwards to tell me what you thought, whether you thought it got tighter, those streaks got better defined, or remained the same, or got worse. You know, any of those things can happen. I'm hoping it'll get tighter, but I can't be sure. So let's try to make an objective assessment of whether they got better or worse or stayed the same. So it's going to read out in now 2 minutes, less than 2 minutes, 90 seconds or so. And in fact, you can see the countdown right here. If I change screens, you can see that it's got another 1.5 minutes to go, 90 seconds to go, so that until this number, the progress bar, will hit the desired integration time or exposure time, just 1200 seconds or 20 minutes. 1 minute, approaching 1 minute to go. Now it's 1 minute to go. 1 minute seems like an eternity when you're waiting for something to happen.
FCS is working great today, right?
What was that again, Aparajita?
FCS is working great today.
It's working very well today. Yeah,
No.
look, tight corrections, yeah. Yeah, that purple box is meant to be a half pixel by half pixel. 0.25 is the half width of the side. Okay, 20 seconds. In 20 seconds, it'll start reading out. The readout itself takes about 40 seconds. And then...
What was the... Yeah, right, sorry.
No, go ahead.
What was the issue with the alignment slit on this mask?
I will try to explain after the readout finishes.
Yes.
Maybe you should change back to the image, Raja, so we can see the...
I will definitely change to the image. I want to get us a little bit closer to build up the suspense. I can actually, you know what, I'll move it here and I can give you a countdown. It's 35% done, but I'll tell you when it's closer. I can see both screens here, of course. It's about halfway done with the readout. Yeah, there were two different problems that we encountered. One with the alignment boxes and one with the image quality, two different problems. And, do you have a hypothesis of what happened with the alignment boxes and a hypothesis of what happened? Okay, get ready. It's about to read out. It'll announce that.
CCD readout complete.
Oh, wow. So you saw the cosmic rays changed. I thought it stayed about the same. It didn't get much better. Didn't get worse. Certainly didn't get worse.
The same, pretty much.
Okay. It's a funky looking cosmic ray here. And cosmic rays generally don't care about CCD boundaries because slit boundaries. These slit boundaries have to do with light coming through the instrument and hitting the detector. Cosmic rays have to do with particles, and they don't, they come through whatever is shielding the camera. So they don't care. All right. The last of the 20-minute exposures, and then we will switch to in fact, if you look at this screen over here in the lower right, you see it says exposure 3 of 3, and it says that it started the exposure. These commands here, WFFCS go I3, stands for wait for FCS, wait for the flexure compensation system to catch up, and then go means go integrate, go start the integration, and 3 means take 3 exposures, not 1. That's what that means. Okay, I was going to check into something else here that was not working before. Let's try this again.
Hey, Raja.
Yes.
You're muted, Rocco.
Yes, please. Go ahead, Jim.
I was gonna see that we are in the align area setting. So I could change it to do the readout of the map. I think it should be better, but you know, we do have this for brain.
Where are you? Can you point me, please, to where you're seeing this?
So there's a
I see, align area. Yeah, okay.
yeah,
So if we were to change that and read out the whole imaging area is what you'd read out, right? Which is only slightly bigger than the mask area.
yeah.
It's not going to read out
What
the,
I don't know is if the alignment tool changes it or not, but I didn't see it as an option,
I see.
but we can change it. I can change it. It'll slow down the readouts.
Just a little bit, but should we do that only for mask 6? Because I think the rest of the masks will be fine.
Yeah, that can work too.
That's the
Or
last
you
one.
can use the box file. The box file will work as well.
Yeah, okay. It may be, magically, it may be that in number 6, that it has the, not magically, it may be that in mask 6, it has things right. But if not, even if it has it wrong, I mean, if it has it right, it'll be an alignment box that it won't recognize as an alignment box. It won't be the end of the world if that's the case. And if it has the same problem, then then the box file will work fine. And yeah, I'm a little worried that even if you change the readout, if I don't know what the slit mask alignment tool is, you know, what route it's taking to take these images, what keywords it's setting. It may well be that if you set it externally, it will just adopt that, but that's what you're hoping, right? So
I think we have a working solution.
I think so too. It'll be interesting. So you have that mask. It'll be interesting to see what's going on there. I mean, not for our run, not for our science, but in general, it might be interesting to troubleshoot what happened there. So for that one, if you were to, that mask is in the cassette. If you want, we can take an image at the end of the night. If you want me to take an image at the end of the night, you know, just with the slit mask imaging tool. Again, I don't know what the imaging tool does. I guess the slit mask imaging tool is yet a third piece of software. I mean, we can directly take images. We can use the slit mask imaging tool, and we can use the slit mask alignment tool.
We can also do that.
Okay, okay, I'll be done. But if you want to test it out, it might be interesting.
Okay.
Thanks.
So, otherwise, I'm going to say good night.
All right, thank you, Jim. Thanks for a fantastic run, really.
Hello, sir.
Hello. Hello.
Sir, I have a question.
Just one moment, please. Just a moment. I'm just running something here. Give me one moment. Yes, please go ahead.
Sir, with the telescope, with the help of telescope, we can see the whole universe.
We can't see the whole universe. We really cannot, because even the part that is referred to as the observable universe, I'll define that in a moment, but astronomers believe that there are parts of the universe that are further away from us than light has had time to travel during the life of the universe. The universe has been around for 13.7 billion light years. So if there are galaxies or stars, the galaxies, not if there are, the galaxies or stars that are located further away from us than 13.7 billion light years, that distance is great enough that light hasn't yet had time to reach us. So it doesn't matter how powerful your telescope is, it can't change the speed at which light travels, so it can't see certain parts of the universe. So the part of the universe that we should be able to see is a sphere whose radius is 13.7 billion light years, because that's how long ago the Big Bang took place. That is often referred to, such a sphere centered on us is referred to as the observable universe, the part of the universe we can observe. Not the entirety of the universe, but the part we can observe. Now, even within that, if you go towards the edge of that sphere, there comes, you're looking back further and further back in time, and there comes a time when the universe was very dense and completely ionized. It was made up of electrons and charged particles, electrons and protons, or even quark plasma. And that material in the universe is opaque to radiation. Light can't travel through it. Just like light can't travel through the table that your hands are on, light can't travel through the walls of the rooms. Materials in the universe, certain materials are opaque. Glass is transparent, air is transparent, but that dense charged plasma was transparent. And so that's how far back, and therefore that's how far out we can look within our observable universe. Not all the way to 13.7 billion light years, but 13.7 billion light years minus something like 380,000 light years. So 13.7 billion minus 380,000 is practically 13.7 billion light years. But my point is, we can't see all the way to the Big Bang. We can only see out to a redshift of about 1,000 when the universe was filled with this dense plasma. That's a very complicated answer to your question. Can telescopes see the whole universe? The short answer is no. Are you happy with that answer? Do you have any follow-up questions? I didn't see who asked the question, sorry. Who was it who asked that question?
Sir, I have a question.
Yeah, yeah, sure. Well, let's go back to the person who asked the question earlier. Who asked the earlier question? Can I have a quick? Can she please?
Sir,
yeah, let's go back to the person who asked the last question about can telescopes see the whole universe. Who asked that, please?
Yes, sir.
Yeah. Were you the one who asked the question?
Yes.
Is my answer okay? Do you have any follow-up questions?
No, sir. Thank you.
Okay. Let's go on to the next question. Sorry, I didn't mean to cut you off. The next person.
how and why does stars' gravity affect time?
What do you mean take time? Can you ask your? What do you mean by stars' gravity take time? I'm not sure I understand your question.
Professor is trying to say how and why does star affect the time? Effect.
I see. Stars have a very minimal effect on time. I mean, so again, I'm not sure I'm understanding the question. Could you repeat the question, please? I don't think I understood it.
So he is trying to say, sir, that how does the stars affect the time?
Stars don't really affect time unless it's very dense and has a very strong gravitational field. Black holes and can at the event horizon of a black hole, at least from our outside perspective, time slows down to a halt. But stars don't have anything near that kind of strength of gravity and the slowing down of time. Time dilation effects on the surface of a star are minimal. How does it slow down though? If your question is how, it really has to do with Einstein's description of gravity, not as an invisible force working at a distance, but in terms of mass distorting space-time. In this sense, stars do affect time, and light that's, let's say, grazing the surface of the sun is indeed going through what Einstein and others described as warped space-time. So mass warps the space and time around it, and anything traveling through that warped space-time, like light or anything else, has to go on slightly curved trajectories. So in this sense, stars do affect time. I don't know if that's answering your question. But the subject that you're asking about, I believe, is called general relativity, which is a subject that Einstein and others developed, and it's a highly mathematical subject. You'd have to study a branch of calculus called tensor calculus, not vector calculus, but tensor calculus. It's a beautiful branch of mathematics, and it's a very, very elegant subject. But it's something that's typically not taught in schools, not typically. I've never heard of it taught in schools, and it's often not even taught in college. It's taught at the university level. Aparajita, did you have to do this for your master's, like GR?
Yeah, I did.
But not in your bachelor's?
No.
Okay. No, same here. I had to do this for my master's and my master's PhD classes. Actually, I had to read up about this on my own before that, but
by the way, I found this reference that says the high temperature of the corona is because of convective nature of the heat transport in the photosphere of the sun.
convective nature of heat transport in the photosphere of the sun.
Yeah.
I think this is similar to what Doug was saying, to do with heat transfer.
Hello, sir.
Hello.
Sir, sorry for my interruption, but
Not a
now we have lunch.
Of course. You all should head out. You have only
Really had
17 minutes.
very nice days
And
with you. Because
yeah, the next time we do a Shadow the Scientist session will be on the 1st of October for you. It'll be the 30th of September for me. 1st and 2nd of October. 2nd of October is a special day. Why is it a special day?
Gandhiji's birthday.
Right, that's exactly right. So on Gandhiji's birthday and the day before that, we'll have the next 2 sessions of Shadow the Scientist, 1st and 2nd. Enjoy your lunch. Thank you for joining.
Thank you, sir.
Thank you. Thanks.
Excuse me, sir. Sir,
Yeah.
hello.
Hi.
Sir, I was having a question, sir.
Say that again.
Can I ask? Sir, I was having a question. Can I ask, sir?
Yes, please. You can ask your question. Yeah, of course.
So I was thinking, sir, what type of food do we eat in space? Is it a special type of food?
Apparently, yes. I am not completely familiar with this. I can find out. I know that at least how it's packaged, how liquids are packaged and how you have to drink liquids is a little different from the way you would eat and drink on Earth, but I'm not completely familiar with what astronauts eat. You can probably read up about this online, but I don't have an answer off the top of my head.
Okay, sir. Okay. Thank you, sir.
Thank you.
So we take our leave now, sir?
Yes, please. Okay, take care. Bye. See you in about a week. Oh, actually, not even a week, a few days. Bye-bye.
Although October 1st is Pujo, right?
Saturday,
Which
huh?
means-
Saturday and Sunday, their time, Saturday, Sunday. For me, Friday and Saturday nights
Yeah.
is when we have.
I don't know if they'll be able to join.
Yeah, yeah. In general, on weekends, they're not able to join because
Oh, right. School.
they're only able to join when they're in school. And Saturday, Sunday is off. So Saturday and Sunday are what, Navami and Dashami?
No, it's Shoshti and Shoptami.
I see, Puja. So this time Dashami is in the middle of the week.
Monjima has asked me to tell you that Bong in Monjima has awakened.
The what has
And-
awakened?
The Bong, the Bengali.
In what sense?
Yeah, she's not in the mood to work or study.
Right now? Okay, good.
Yeah.
Good. Well, I haven't done my bit of emailing Astro 12 and 16. I've just been too busy.
Yeah. I have been trying to install the Karma Python library.
I see.
This
This is for the power spectrum analysis?
Yes,
Okay.
yes, and I have not been successful so far.
Okay.
Well, it doesn't actually have a Windows distribution. You can only run it on Unix machines.
I see.
So I set up a virtual Linux machine. I set up a virtual machine and installed Ubuntu on it. And then I tried to install it, but it's complicated because I think the C libraries that it's compatible with, that hasn't been updated in a long time.
I see.
So I probably have to track down old versions of GCC and the C libraries and everything.
I see.
Yeah. I wonder if there's an easy alternative. I mean, it does MCMC. I think it helps MCMC. I don't know. Simulations.
Markov chain Monte Carlo.
Yeah.
The goal
It's
is
an
to measure
MCMC
the.
sample.
Sorry, say
I'm
that
not
again.
It says it's an MCMC sample.
I see. Look, the goal is to characterize how these objects' brightness is varying. So statistical characterization of the time scale, the variability of this object as a function of time scale. That's basically what the power spectrum is trying to measure. The people who sent us the code, is it worth asking them is a question.
Probably, yeah.
Okay, I'm going to check on one thing quickly. Let's see. It's reading out, so we should go to the next object. Sorry. I think we go to the next target, you guys, right? Arena, we are ready to move to the next target. I'm going to highlight the target. So M31, M32 RD2. Thank you. I will get this ready for alignment.
CCD.
Again, I don't think it changed very much. The cosmic rays changed, but it didn't. We did not. No, we did. Oh yeah, we did D1. So we want the, sorry, thank you, Rina. We did D1 yesterday, and we want to copy the coordinates and position and rotation of D1.
Okay.
Same as D1, exactly. Thanks. Thanks for reminding me. I'm so spaced out today. So I do want to, while this is setting up, I think this is good. We just changed the mask name, which is loading, set the grading to 0th order. You want to go to course alignment, do things, or you want me to do it from here?
Yeah.
We'll just go to final line directly. That's right, no course align. So the mask is in place, and okay, just another second and this will be ready. There we go, ready. This is very efficient, this mask alignment. So we're lining up a second mask, and we'll get a chance to measure how good or bad the image quality was. So it's a bit of a mystery as to why the image quality got so bad, like 1.5 arc seconds. All I can think of is the temperatures and things like that have changed between when we first did Amira and later on. I think it's a lesson to not do Amira too early. I think that's the lesson I'm learning. Yeah, I think, or yeah. That's what I'm guessing. That's the only guess. I mean, there were two separate issues. One is the image quality, the second is the mask. But I think we'll just let's soldier on through these one after the other. After D2, we'll do. Fingers crossed. So I think we got good data in 3 times 20. Oh, good. So I think if we X out number 3, we're in good shape. But you want to X out 3 just to make sure it's not being included in anything. Oh, wow.
Wasn't it already?
Oh, I see. Okay, that's what it was. Okay,
Yeah.
already X'd out, sorry. So I think you can do send moves only.
Yeah.
Perfect. Okay. I'll take this over again, then I'll go on to this thing. So we are aligned. It was actually a very small move. So this is set. We just want to restore this. And I want to copy the image name over from here. And we want to do a 3, but I want to wait for this to get out of lockout and enter here. This is very efficient, really efficient. And I think all of these are repeat except any 7, so we should be quick with this.
Yes.
I'm hopeful we'll get all 7 tonight.
Realignment.
Yeah, and it's it's 2 hours 45 east still. So we have another 6 and a half to go, 6.5 hours to go, in which we're trying to observe 6 masks. That's tight. Am I doing this correctly? 2 hours 45, 6.5 hours to go. We're trying to observe 6 masks. That is going to be tight. Math correct? What time is it? 4:30. So maybe 6 hours, little more than. We started the alignment already, so 6 hours 40 to go for. Yeah, please go ahead. Go ahead. It's still seeking. It hasn't yet. Now we get to play with this.
This is an emergency. Okay.
What is that?
It said emergency for a second.
Oh, okay.
Yes.
It just does that too. make sure we're awake. So we're just waiting for the flexure compensation system to catch up. Where did you see it?
Here, a flash. for a
Oh, I see.
second.
Okay.
turned
Stop,
to-
stop it, stop it, stop it. So we're waiting for the FCS to catch up. It is sort of cycling through this emergency thing. I did see it happen a few more times. It's happened with FCS. Man. We may have to call Jim. Something is going on.
Yeah.
It's just stuck. It's just stuck there. And after it says FCS is reading out, finished writing to disk, cross correlation failed, image is too contrast. I think a phone
Yeah,
call,
you're right.
it's not moving at all. Rina, we need to call Jim because the FCS has failed. Just as we were patting ourselves on the back for a quick alignment, it failed. I don't know what to do exactly. See, it keeps giving this message. Cross correlation failed, image contrast too low. I mean, I could try changing this wavelength and sending it back. Sometimes that's what. Okay, Rina's talking to him, so I won't. In the meantime, I'll calculate what the seeing was, what the seeing is while we're not getting data. We didn't change anything. We're not sure why it happened. 0.7.
Emergency.
The only bad thing we did was we were gloating about quick alignments. That's the only bad thing we did. Yes. Hey, Jim, sorry. Sorry, Jim, to bring you back to. So this happened while we were trying to go back to 7800 from a fine alignment, but
Yeah, I don't think it's you don't have a do you have a way for FCS? So let's cancel that.
okay.
And
So that's from the actions menu. That is a big shift. I can see that. Yeah.